In this example, we're given information about two events. And the first piece of information that we're given is what I just highlighted here. It says that E and F are mutually exclusive events. And what that means is they can't happen at the same time. So if I imagine that this circle represents event E and this circle represents event F, there is absolutely no way that they can overlap and happen at the same time. If they overlapped, then I would have a piece in the middle here where those two circles overlapped. So this gives you a visual representation of what's going on here. And then an actual example of something that's mutually exclusive might be two events that I call event A, my car is a Honda, or event B, my car is a Ford. Now, those two events can't happen at the same time. Either my car is a Honda or it's a Ford. It's not possible for it to be both at the same time. So I would say that the probability of my car being a Ford and a Honda is 0 because it can't happen at the same time. So that's the same thing that's going on here. Even though it doesn't explicitly say it, we can add to this problem of what we know. We know that the probability of E and F happening is going to be equal to 0. It's impossible for those two to happen at the same time. So that's one piece of information that we know. We're also going to use this information that was given to us about the probability of E and F. So if you notice here, I wrote down the general formulas for the probability of an and statement. So in general, we would have the probability of an event E and F happening, and then here's the formula. Okay, so we're going to use these formulas to figure out the probability of E given F. So if I write down here the probability of event E and F happening is equal to, now I'm using this formula up here that I just boxed in blue. This is our general formula. The probability of E happening times the probability of F, given that we have E, and then the other formula is the probability of F. I can switch it around and say that that's equal to the probability of F times the probability of E given F. So I can write it either way. Now, because what we're trying to find is the probability of E given F, I'm going to use this formula here. So I narrowed it down to which one I'm going to use. So I have the probability of E and F is equal to the probability of F times the probability of E given F. This is the formula I'm going to use. Now, underneath the probability of E and F, I'm going to write 0 because we know that that value is 0. We just talked about that. The probability of F happening is 0.3. That was given to us in the problem. And this is what we're looking for. So just like you were solving an algebraic problem, think about, since this is what we're looking for, I'm going to label that as x, and I'm going to solve for x. So in order to solve for x, I'm going to divide both sides by 0.3. And now, because I can cross off this 3, I can say x is equal to, and then I get 0 divided by 0.3, which is 0. So that tells me that the probability of E given F is 0. And that makes sense because we said that this was mutually exclusive. In other words, if F happens, because that's what this assumption is saying here, we're assuming that F has happened, and now we want to calculate the probability that E has happened. If F has happened, then the probability of E happening is 0 because we said they can't happen at the same time.